page 5, topic 2B. We're going to do the following problems on page 5, continuing our study of linear equations and how to solve them. So the problems that we're going to do are 8, 13, 16, 18, and 20 on this page 5. So let's start with the first problem. And in this problem, let's read it over. Number 8, we're told if 4 is added to a number and this sum is doubled, the result is 1 less than 3 times the number. And we have to find this number. So we start off with our let statement. This is the number we're looking for. And it says if 4 is added to a number, so we add 4. And then this sum is doubled, so we're going to put a number 2 in front of the x plus 4. This gives the sum is doubled. And this number is 1 less than 3 times the number. So it's going to be less than 3 times the number, which means we have to add 1 to the number to make it equal. Now what we could do also is subtract 1 from this to make it either. So this line and this line are the same. Now we'll use this line here, and if we use the distributive rule, we're going to get 2 times x is 2x, 2 times plus 4 is 8, and then the right side stays the same, so we get 3x minus 1. Now we're going to bring the variable to the left side, so all the variable terms to the left side. The 2x is there already. The 3x is on the right. I'm going to bring it over here to the left. And the numbers we're going to bring to the right, and minus 1 is already on the right here. And the plus 8 that's on the left, we're going to transpose to the right side and change the sign. So the plus 8 here becomes minus 8 here. So 2x minus 3x becomes minus x right here. And minus 1 minus 8 becomes minus 9. So minus x becomes minus 9. We can multiply both sides of that by minus 1, and this is the same as saying that x equals 9. So now we check this number. 9 is the solution to the equality. And what we're going to do is add 4 to the 9, because we go back, right here, we add 4 to the number, and we double it, gives us 26. 26 is 1 less than 3 times 9, or 27, which was in the original statement right here. So the number x equals 9 is the appropriate solution to this problem. Okay, let's go to the second one that we're going to do, which is number 13 on page 5. And we're told that the sum of 3 consecutive odd integers is minus 21. And we're asked to find the integer. So we let x equal the first odd integer. Now, in order to go to the next consecutive odd integer, we have to add 2. For example, if we were thinking about the number 3, and we wanted, which is, let's say, the first odd integer that we may be considering, the next odd integer has to be 5, which is 2 more. And the third odd integer has to be 3 plus 2 plus 2, which is 7. So 3, 5, and 7 would be 3 consecutive odd integers. Here we're going to say let x equal the first odd integer. The next one after that has to be 2 more. And the next one after this one has to be plus 4. So we have the first odd integer is x, the second one is x plus 2, and the third one is x plus 4. Now we're going to add these 3 consecutive integers, and we're told that the sum is minus 21. So we're going to add x, which represents the first, x plus 2, which represents the second, and x plus 4 represents the third, and that sum should be minus 21. We add the x and the x and the x here, we get 3x. We add the 2 and the 4, we get plus 6. This equals minus 21. We bring the plus 6 from the left side to the right side. It becomes minus 6. So minus 21 and minus 6 become minus 27. If I divide this by 3, I get x. And I divide minus 27 by 3, I get minus 9. So the first odd integer is minus 9. Then minus 9 plus 2, or minus 7, is the second consecutive integer. And minus 9 plus 4, or minus 5, is the third consecutive odd integer. So the sum of these integers, let's check them out. Minus 9, minus 7, and minus 5 sum to minus 21. And that's exactly what the problem should indicates that this answer is correct, because we get the sum of these 3 consecutive integers as minus 21. Okay, let's go to the next problem, number 16. And here we're told that 3 consecutive odd integers, we have to find them, 3 times the middle one is 1 more than the sum of the other 2. 3 times the middle one is 1 more than the sum of the other 2. In other words, the middle one is 3 times, is 1 more than the sum of the first and the third. Okay, so we let x equal the first odd integer. X plus 2 is the second consecutive odd integer, and x plus 4 is the third consecutive odd integer. 3 times the middle one. Well, the middle one is this one. 3 times that is 3x plus 2. This is 1 more, so I have to subtract 1 from it to make it equal to the sum of the other 2. The sum of the other 2 are x and the x plus 4. So because this is too much by 1, I subtract 1 to make it equal. Now, if I use the distributive rule, 3 times x is 3x. 3 times plus 2 is plus 6. Now the minus 1 is the minus 1. This is x here. Remove the brackets. I get x here. And this is the 4 here. So 3x plus 6 minus 1. 6 minus 1 is 5. 3x stays the same. X plus x is 2x. And I've got the plus 4 here. Now I bring the 2x from the right to the left and change its sign. I bring the plus 5 from the left to the right and change its sign, and I get x equal to minus 1. So the first integer is minus 1. Then the middle one is minus 1 plus 2, which gives me plus 1. And the third one is minus 1 plus 4, or 3. So the middle one is 1. 3 times the middle integer is 3 times 1, which gives me 3. The sum of the first and third, well, the first is minus 1, and the third is 3 right here. If I sum those two, I get 2. The middle integer is 1 larger than 2. 2 is the sum of the first and third. 3 is the middle integer. Okay. Actually, 3 here is 3 times the middle integer. 3 times the middle integer. Okay, next problem. In a cinema, there are 25 more men than women. How many of each are there if there are 139 people in the cinema? So, we let X equal the number of women, and we're told there are 25 more men than women. We start with the number of women, being X. The number of men is 25 more, and the sum of the men and the women is, women and the men is 139. So when we sum this and this term together, we get the total number of people in the cinema. That's 139. So removing the brackets, X plus X gives me 2X. And I have the 25 on the left equals 139 right here. I transpose the plus 25 on the left to the right. It becomes minus 25. 139 minus 25 is 114. I divide 2X by 2, I get X, and 114 by 2, I get 57. So this is the number of women right here, 57. If I add 25 to that, I get the number of men, which is 82. 57 plus 82 equals 139, and that's exactly what the problem reads. So I know that I have the right answer. Okay, the next problem reads as follows, number 20. A grant of $20,000 is to be divided into 3 scholarships. How much is given to each scholarship if the second is double the first and the third is $2,000 more than the second? So we're going to let X equal the first scholarship amount, and 2X equals the second amount because it's double. How much is given to each scholarship if the second is double the first? So that means that the second is this. The third amount is 2,000 more than the second amount. The third is 2,000 more than the second amount right here. So we just take the second amount and add 2,000. First is X, that's the first amount. The second is double that, so it's 2X. And the third is the second plus 2,000, which gives us the third amount. Now the sum of the first, second, and third has to give us the total amount available for the scholarship, which is $20,000 right here. Now, if I remove the brackets here, I get this X is this X, 2X is 2X, this 2X is this 2X, this 2,000 is this one right here, and here's the 20,000. Now what I do is I remove this plus 2,000 from the left to the right, and I get minus 2,000. So the plus 2,000, which is a number, I want to move it from the left side to the right side, and I change the sign. That's the only change I have to make here. X plus 2X gives me 5X, and the 20,000 is there, and I've moved this from the left to the right, so I've changed the sign. 20,000 minus 2,000 is 18,000. I divide the 5X by 5. I get X. I divide the 18,000 by 5, and I get 3,600. So the base scholarship is 3,600 or 3,600. The second one is twice 3,600, so it's 7,200 is the second amount. And the third amount is 2,000 more than the second one. So I have 2 times 3,600 plus 2,000 is 7,200 plus 2,000, which is 9,200 or 9,200. And so I know the first, I know the second, and I know the third. And if I sum them, they add up to 20,000, which they should. In other words, 3,600, 7,200 gives us 10,800. 10,800 plus 9,200 gives us the 20,000. So we know that we have done this problem correctly. Now let's move to page 6. And on page 6, we're going to do 3 problems, number 22, number 24, and number 25. 3 representative problems. So, we're told in number 22 that a child has a collection of pennies, nickels, and dimes that total $3.65. How many of each did she have if the number of nickels was 5 more than the number of pennies and the number of dimes was 14 less than the number of pennies? So first we're going to calculate the number, or set up a statement that gives us the number of each one of these coins. So statement says how many of each did she have, so we want the number of pennies. The number of nickels is 5 more than the number of pennies. NO is the abbreviation for number. And the number of dimes is 14 less, so I subtract 14 from the number of pennies because that tells us the number of dimes. Now, so what I've identified is the number of each coin that I have, number of pennies that I have, the number of nickels that I have, and the number of dimes. Now, if I want the monetary value of each coin, I have to multiply the value of one coin of one of each of these coins in cents times the number of coins. So how do I apply that? In the case of the monetary value of the pennies, I have to multiply the value of one coin of a penny is 1 cent, and I have X number of coins. Because I have to, in order to get the monetary value, I have to multiply the value of the individual coin times the number of coins that I have. So in the case of the penny, each coin is worth 1 cent, and X is the number, so the total number is X. For example, if I had 5 pennies, I would multiply 1 times 5, and I would get 5. If I had 17 pennies, I would multiply 1 times 17, or 17. Now, for the number of nickels, the monetary value of each nickel is 5 cents. So this is the value of one coin in cents right here. A nickel is worth 5 cents. In this problem, I have X plus 5 nickels right over here. So there's the monetary value of the number of the nickels in this problem. And in the case of the dime, each dime is worth 10 cents, so I multiply the monetary value times the number of coins, which is X minus 14, and that gives you the monetary value of the dimes. Now, I want the value of the pennies plus the value of the nickels plus the value of the dimes. That's what I need, and I know that equals 365 cents, or $3.65. So I know right here that the monetary value is $3.65. So now I set up my equation right here. So here is the value of the pennies. This is the value of the nickels. And this is the value of the dimes. And the total must be 365 cents. Everything's in cents. So I need the value of the pennies, I need the value of the nickels, and I need the value of the dimes. Here's the value of the pennies. Here's the value of the nickels. 5 cents times the number that I have. 10 cents is the value of an individual dime times the value times the number of coins that I have, x minus 14. So now if I remove all the brackets, I get x plus 5x. 5 times 5 gives me 25. 10x right here on the distributive rule. 10 times minus 14 gives me minus 140. I get 365. Now what I'm going to do is keep the variable terms on the left. X, 5x, and 10x are on the left. And I'm going to remove the 25 and the minus 140 to the right, and they will change sign. So these two terms here are moved from the left to the right. In this here, it's plus 25 becomes minus 25. Minus 140 becomes plus 140. And if I add these and then subtract this, I get 480. So 16x equals 480. So x equals 30. So the number of pennies is 30. I have 5 more nickels than pennies, so I have 35. And the number of dimes is 14 less than the number of pennies. So I have to take this, subtract 14, and I get 16. So I now know that I have 30 pennies, 35 nickels, and 16 dimes. If I take the total value of this, 1 cent, and I've got 30 of them. I've got 35 nickels multiplied by 5 cents each. That gives me the total monetary value of the nickels. I have 16 dimes, each worth 10 cents. So that gives me 160. 1 times 30 gives me 30. 5 times 35 gives me 175. 10 times 16 gives me 160. If I add 30 plus 175, I get 205. 205 plus 160 gives me 365. Let's go to the next problem. And here we're told, or the problem indicates, how much money did a woman have? She had $7 left after spending 50% at one store and 30% of the remainder at another store. So in this problem, we start by trying to figure out how much the woman had before she started shopping. So here we're going to say let X equal the dollars the woman had before shopping. Okay, because that's really what the story asks. How much did a woman have if she had $7 left after spending 50% at one store and 30% the remainder at another store? So we'll say before she even started, she had this much in her wallet or billfold, X dollars. Now she spent 50% of this, which is 50 over 100 of the original amount X. If you reduce this to a fraction, it's X over 2. So that's what she spent. She spent half her money in the first store. Well, if she started with X and she spent 50%, 50% is a half. You reduce 50 over 100, you get a half. She spent X over 2 in the first store. Now, how many dollars did she have left after shopping in the first store? Well, she started with X, but she spent half of it in the first store. So she was left with X minus X over 2. It says here she spent 30% of the remainder in the second store. So after she'd gone into the first store and spent half of it, she spent 30% of the remainder. So what I've done here is to show you, well, there's the amount she had after she spent her half in the first store. 30% is 30 over 100. Of the remaining amount was dollars spent in the second store. This is what she spent in the first store, and this is what she spent in the second store. So, dollars before shopping was X. Dollars spent in the first store was X over 2. And dollars spent in the second store was 30% of the remaining amount, which is this. And that equals $7 because we're told that right over here. She spent 50% at one store, 30% of the remainder at the second store, and then after that she had $7 left. So we know at the end she had $7 right here. This is what she started with. This is what she spent at the first store. Okay. And this is what she spent at afterwards. After leaving the first store, she spent 30% of what she had left. So now, if we make all of these decimals, this X is this X. X over 2 is 0.5X right here. 30 over 100 is 0.3. This X is this X, and this term is this term, and this equals 7. So if we use the distributive rule here, we get minus 0.3X minus 0.3 times minus X, minus 0.3 times minus X over 2 gives me 0.15x. So you see that each one of these terms is a term in x on the left. And I've combined them. There's an implied 1 in front of this. Minus 0.5 right here. Minus 0.3 plus 0.15. So that's all over here. And that leaves me with 0.35. Of course, there's an x because each one of these terms is a variable. So 0.35x equals 7. And now if I divide the left side by 0.35, I get x. If I divide the right side by 0.35, I get 20. This means that the lady had $20 before she started shopping. Now, she spent 50% at one store, in other words, $10. So she was left with $10. 30% of the remaining $10, because she started with 20, spent 10 in the first store. 30% of the remaining $10 is $3. So 20 minus 50% minus 30% of this $10. 30% of $10 is $3. That gives me the $7 right here. So let's go to the next problem. And this is the last problem. And here we're told that a plumber charges $80 per hour for labor. How many hours did he work on a job if the total bill of $14.60 included 900 for parts? So the total bill is $14.60. Let X equal the number of hours that the plumber worked. Now the total bill is made up of two parts. Total bill is made up of two parts. One is the parts cost and one is the labor cost. So let's look at the labor cost now. The labor cost is determined by a rate per hour times the number of hours worked. So we know that he charges $80 per hour, and the total labor cost is determined by multiplying his rate per hour times the number of hours worked. So for example, let's say he worked 5 hours at $80 per hour. His labor cost would be 80 times 5, or $400. If he works 8x hours, it's going to be 80 times x. So there's his labor cost. So now when we have the total bill, which is $14.60 right here, we know it's made up of a parts and a labor cost. See this? This is coming from the labor cost right here. 80 times x. Now what we do is we transpose the left side to the right and the right side to the left. I don't even have to change the signs. If this equals that, then the reverse is true. This must equal that. So I'm just reversing these terms and I get 80x plus 900 equals 1460. And now I move the 900 from the left side to the right side, and that's why it changes sign. I get 80x equals 560 because 1460 minus 900 is 560. So I get x equals 7 because I divide this by 80, and I divide 560 by 80, and I get 7. So parts are 900. The labor cost is 80x, 80 times 7 hours, because that's what we computed, 560. 900 plus 560 equals the 1460. So that, and we know that 1460 from right here. So this completes topic 2. And I think you should be able to now be able to do the other problems on this page and be able to solve most linear equations.